Okay, ladies and gentlemen, warmly welcome also from my side to the next session about 3D and camera technology here at the Industrial Vision Days. The former host of the session, Ms. Anne Wendel, has managed to finish perfectly in time, so thank you for that, Ms. Wendel. We will now go on with the last presentation of the 3D session, and our next speaker will be Mr. Peter Vandersteegen from the AMS company, who will give us a talk about near-infrared 3D sensing with active light sources. So, Mr. Vandersteegen, the stage is yours. Please provide us with your presentation.
Okay, thank you. And good morning, or almost good afternoon. So I will be talking about industrial 3D sensing. And what you will find is the company I work for, basically we are a component seller, and these components include both imager and illumination sources. And so I will present how we make a product portfolio fitting with respect to this end market. I made this together with my colleague Jörg, who is responsible for the illumination. I'm responsible for the imager side, but it's basically a joint effort to show you what kind of components we have to enable industrial 3D sensing. With respect to what is AMS Osram, we are basically a component player. We do have illumination, we do have imagers. It's a company which has recently, let's say, become one. And it's interesting because, in essence, what we now have is technical capabilities going from small camera modules to relatively large illumination solutions, going from UV to infrared. So we do have a quite vast reach of interesting technology. So from an engineering perspective, this is a very interesting field to play in. But when it comes to industrial, I wanted to first sketch the market space. So what you see here is basically enhancing the sensing landscape in industry. So in the past, when you look at our imager portfolio, we were mainly focused on image sensors, which were really focused on quality inspection. But what we also see, and this was already presented in the morning, is that, and this is also very interesting, at this moment there are quite a number of emerging fields. Think, for example, of access control, think, for example, of industrial IoT and automation, where, let's say, small camera modules, which are capable of 3D, become a very interesting solution for these end markets. So, for example, industrial IoT, we currently have automated guided vehicles inside of big logistical centers, and that's let's say, an end application which was not present 10 years ago. But these end solutions do benefit from a 3D solution. So that's something which we try to address with the solutions which we currently are developing. Maybe not something which I'm, let's say, going to depth in this presentation, but with respect to industrial, we also have a pretty interesting portfolio with respect to UVC disinfection, which is also a very popular topic now. But in a nutshell, we have a quite range of technologies to address, let's say, the quite scattered industrial landscape. And within that landscape, we also believe that 3D will become or will be a very important technology to have in-house. So, and what we offer is basically the key components. So it's not that we make camera systems, that is not what we do, but we do make the camera modules. And what I try to illustrate on this particular visualization is sort of the what kind of technologies are out there and when do they fit the most, and what kind of components do we put against that. So y-axis is sort of what kind of depth map and resolution do you have, and then the y-axis, or sorry, the x-axis is what kind of range could happen. So in the first presentation, we already, let's say, touched upon indirect time of flight. We also saw it in one of the later presentations. A very interesting technology, so far relatively limited in resolution. What we do offer in this domain is basically the flood illuminator. If you, however, have an end application where resolution is important, multiple technologies coexist side by side, depending on, let's say, the distance you're looking at. And with respect to active illumination, one of the technologies which we have in-house is structured light. Combine this with an image sensor, you do get a depth map of 1 megapixel. If you have then, have an end application where you actually want to look somewhat further, we also have in-house the capability to support active stereo vision. What is active stereo vision compared to normal stereo vision? It's basically using a normal stereo vision camera, but complemented with a dot pattern. That dot pattern enables also to sort of impose a structure on a very homogeneous background. So for example, if you have an AGV moving around in an area with white surfaces, having a structured light solution will enable you to actually map or have a good 3D perception of, let's say, a very homogeneous background. In addition, active stereo vision compared to stereo vision will enable you to actually have, let's say, it's a more robust algorithm. The AMS products which we have here is really dot projectors, imagers. And what I will try to explain in this presentation as well is what we believe to be the key properties of the products or the AMS products which are needed for these kind of end applications. So, and that is mentioned on this slide. Here you basically see the, let's say, components, and what you will find is we go from flood illumination modules, dot projectors, and image sensors. And in a nutshell, for us, it's about power efficiency and footprint, meaning that the camera modules which need to be made have to be, let's say, confined in a small space. And in addition, they need to consume as little power as possible. On the one hand, because they're battery-powered solutions. On the other hand, because it's really about heat dissipation. If you need quite some, let's say, illumination power to image a specific area, yeah, it's very difficult. So, and for that perspective, we do try to make components which are very power efficient. So for flood illuminator features, homogeneous field of illumination will be crucial. So that could be used in indirect time of flight. Again, low power consumption, compact system design. Dot projector, I think here one key feature which we do offer is basically a random pattern. So this is something which I will present in a later slide, but we do offer random pattern, and the technology which we use for a dot pattern is micro lens arrays. There are competing technologies as well, which we have in-house as well, but I will explain why we believe that for industrial 3D sensing, a micro lens array is the more interesting proposition. And then lastly, when it comes to image sensors, the solutions for illumination you have seen before, so the flood illuminators, the dot projectors, are really focused on the IR, so 850, 940 nanometers. The image sensors, therefore, the image sensors which we develop, we really focus on high quantum efficiency in this wavelength range to enable you to lower the illumination power. Combine high quantum efficiency with an optimized pixel pitch, we have a very high sensitive, let's say, image sensor. Also here, the real focus point is to lower the system power consumption as much as possible. When, let's say, offering you these components, obviously you need something to start. I just wanted to illustrate on this particular slide. We do have specific systems to start from to evaluate specific technology capabilities. We do have reference kits which are focused on 3D authentication. We also have a very interesting evaluation kit for robotics. This evaluation kit is interesting mainly because it contains a number of, let's say, competing technologies in one. It contains structured light, it contains multiple image sensors, it does contain different baselines in such a way that you can play and optimize for your end application what you want to do. And obviously, if you're only interested in the imager, if you're only interested in the illumination, we do have specific evaluation kits for that as well. Now, taking one step back, coming back to the component, and I'm mainly referring to the dot projector, we do have two competing technologies side by side. On the one hand, the technology we focus on in this end market is micro lens arrays. This is competing with diffractive optic elements. The difference between one versus the other is that the diffractive optics elements will enable you to get high density, high quality dots. So that's quite beneficial. The drawback is basically the alignment. Alignment meaning that you actually need, it's a pretty expensive technology. micro lens array, and this is something which I will present in later slides as well, is giving you, let's say, a solution which is stable over temperature, but also stable in respect to assembly processes. So from that perspective, it's a more cost-effective solution while not compromising on accuracy. And this is enabled by basically a block matching algorithm, of which we actually have, let's say, if you work with us, we do have this technology and these kind of collaterals in-house. So let me walk you through the differences between structured light through dot matching and through block matching. So through dot matching and block matching, in essence, they start from the same algorithm mindset, meaning you try to project or you try to find a reference pattern, and the displacement of this reference pattern when you project it on top of a surface gives you the 3D map. The difference is basically how do you determine, let's say, the specific dots. In case of dot matching, so when you work with a diffractive optic element solution, so a dot pattern projector which uses dots or DOEs, you will find that you really try to find the individual dots. With respect to block matching, this is less the case. There you really take areas based on obviously the structured light solution to actually find which, let's say, and then you try to find a specific map, and the displacement of that map and triangulation then gives you the 3D map. So it's really, in essence, the same algorithm which works behind it, but working slightly differently to find the specific dots or blocks to find the displacement in 3D. If you then translate this to product portfolio, this is giving you a complete overview of the product portfolio, and what it is giving you is on the one hand the dot patterns. So on the one hand that's the Belize, where you basically have a solution which is 850 nanometers. Also here the dot pattern which is being projected is quite regular, so you basically would need 2 illuminations to create a sort of randomized pattern, which is beneficial for your algorithm, makes it more robust. If we then go one step further, you go to Belago 1.1, Belago 1.2. Here the difference between each other is more dots. Belago versus Belize is on the one hand different wavelength, 940 nanometers. The benefit of 940 nanometers versus 850 nanometers is really about 940 is completely invisible to the human eye. 850, depending on the intensity, there could still be a residual effect. And that's something which in some use cases is not wanted. With respect to the Belago, and this is an important one as well, we do include an eye safety circuit, meaning that if for some reason during the operational lifetime the package is damaged, we will make sure that the circuit or the chip will be basically will no longer illuminate. And this is important because you definitely want to make sure that during operation nobody gets blinded. So that's one point with respect to the dot pattern. If we then translate this to the imagers, we really focus on footprint and quantum efficiency. Not going into too much details, we have multiple resolutions. So far we are sampling the 1.3 and the 2.2. Other resolutions can be discussed depending on NDA, but here it's really about power efficiency and quantum efficiency and footprint. And this brings me actually already to the conclusion, meaning that what I wanted to convey with this presentation is really that AMS OSRAM has a wide range of components which enable you to make a system which is capable of 3D in more, let's say, in the growing embedded 3D camera space. We have dot projectors, we have flood illuminators, we have image sensors. We have quite a number of supporting systems to enable you to start your design in. And as I mentioned, it's not necessarily about the classical, between brackets, quality inspection system. It's really about new emerging fields where 3D sensing might be very interesting. Think, for example, automated guided vehicles, authentication, and even going beyond industrial, think, for example, specific consumer spaces. So that was the presentation. Thank you for your attention.
Okay. Okay, Thank you, Mr. Vandersteegen, for the very nice presentation, bringing together all the products, the components, showing what you are having for supporting systems. And we now have time for some questions. So everyone is invited to ask questions. Use the information on the upper left on your tables to ask your questions via the online platform. We are open for every question which is answered. So, and we will now continue with the question and answer part. So, first question, you showed on your last slide some application examples. What are the key applications you want the products and the supporting system from AMS OSRAM running?
Yeah, that's well, the ambitious answer would be all of them. But where we see actually a very interesting market traction is the authentication space. So that's one space. And then in addition, where we see, and this is less industrial, more, well, actually, you could argue, is this still industrial, is this still consumer? And the other field where we actually see some traction is really about home appliances. Home appliances, think for example, robotic vacuum cleaners. There, obviously, you also have competing technologies. We do believe we have components addressing all of them. We now only created a, let's say, specific subset, or presented only a specific subset for those.
Okay, thanks for explaining that. Okay. Last question from the audience. How complex is it to get the supporting systems running? Are they easy to order?
At this moment, we do see that the demand is relatively high. Yeah. So that's from that perspective. Well, we do have quite some systems, but yeah, that is something maybe. If there is interest, our booth is over there. Maybe we could discuss this in more detail. What is the need and the demand, and which system is of interest? But yeah, our booth is over there, so please reach out to us.
Okay, thank you, Mr. Vandersteegen. Give a last applause. Thank you for answering the question, and you're now free to go.
Thank you.